So in our last video, we had a relation that was reflexive, symmetric, and transitive. And in that case, we give it a special name. It's called an equivalence relation. So we'll say a relation R defined on a set A is called an equivalence relation if R is reflexive, symmetric, and transitive. So if you look back at our example from our last video, which was reflexive, symmetric, and transitive, you could say that that is an equivalence relation. So let's look at another example here. So I'm going to consider the relation R defined on Z by A relates to B if A equals B. Prove that R is an equivalence relation on Z. So if you're proving that R is an equivalence relation, you have to show that R is reflexive, symmetric, and transitive. So your proof is going to have 3 parts. So call this first one part 1 of our proof. And what you need to do in this part 1, show R is reflexive, well, how would the proof work for R being reflexive? You need to pick an arbitrary integer A. And remember, our relation is A equals B. Well, A is equal to itself, right? So since A equals A is related to A. Therefore, R is reflexive. All right, and then part 2 of the proof. Now, when you're writing these proofs, you don't need to write these parts in red. I'm just doing it so we can see how to write this proof, but you need to show R is symmetric. So how would the proof work to show that R is symmetric? You're going to assume that A is related to B. Since A is related to B, we know A equals B. But since A equals B, we also know B equals A. So since, I'll say, therefore, B is related to A and R is symmetric. So we've shown that this relation is reflexive and symmetric. The only other part that we need to prove in order to show it's a equivalence relation, you need to show R is transitive. So we're going to write the proof here. We're going to assume A is related to B and B is related to C. And remember, what you need to show at the end is that A is related to C. So what do I know? I know since A is related to B, A equals B. Since B is related to C, I have that B is equal to C, but now I have A is equal to C, since A equals B and B equals C. So I can conclude A is related to C and R is transitive. So I've shown that since R is reflexive, symmetric, and transitive, R is an equivalence relation. And that completes my proof right there. So again, if you're showing something's an equivalence relation, you have to show all three things. You have to show that it's reflexive, symmetric, and transitive.